Hello everyone. Today we are going to see how to do image processing with a database. So strictly speaking, we are not doing actual image processing in database. We are just calculating Euclidean distance between two vectors. So I hope if you are interested in how the Euclidean distance have anything to do with face detection, you can read this paper. I will leave the link in the description. So what we are essentially doing is we are generating a 128 numbers for every face. Like this number will be unique for each face, and if if the distance between two vector is under a certain threshold, we can safely say those are same phase. So what we do is we get an input, we will input image, we will calculate the phase embedding and store it in the database, and we will do it for all the images for the data set, and we will get a new sample size, sample image, and we calculate the 128D vector for that image, and we will we will compare that incoming value to the entire database and which one is closest to it. Euclidean distance is the smallest between the database and the incoming value. If it is extremely small, then we can safely assume that those two faces uh, are from a same person. Okay, so that is essentially how face recognition works. And so I'm actually not well versed in how the mathematics behind it works, but I'll link this paper in the description and you can just read it. Uh, so if you want a Python example without using any database, you have this in DLib's website. Actually, DLib is a machine learning tool. It is a toolkit for machine learning. So it is similar to TensorFlow. It has for C++ and Python only, I guess. So yeah, let me jump to programming. So I am just going to clone this repository. So I'll just start fresh. I am just going to open CVTute. Just going to remove the existing file. Git clone the repository. So it is cloning. In the meantime, we need to do some other things, like we need to install dlib. We need to install psycopg2. This is the database driver for Python. This will we will use this library to communicate with the database server, which is PostgreSQL. So I will just show you in a minute how to configure the database server using Docker. So you will have a Docker Compose file in the repository, and you can just run Docker Compose up, and you're good to go. If you are already configured Docker and Docker Compose environment in your system. Here I'm not going to show you how to configure everything, like configure Docker Compose, Docker, those things. So you can just Google it and install it. And I have Docker version 20.10 installed currently. Okay, so it doesn't matter which version you're using. So I already have a Docker thing running here. So Docker Compose down. So the file is cloned now. It is cloned. So I'm just moving into that directory. So This is the directory that we have here. So this is the repository that I have pushed to my GitHub page. So you can just open Visual Studio Code here. So we have the Docker Compose file here. So once you install Docker Compose, you can just come to this directory and run Docker Compose up. Docker Compose up. Actually, let me execute it in separate console so that you can see it clearly. I guess you can see Docker Compose up. So it is creating some so if you run this for the first time, Docker will pull all the images from the cloud and the Docker images will be populated and then it will start executing it. So since I have all the Docker images locally, it is just executing it right away. And now if you run it straight away, you will see this error here. It is due to an issue in file permission, directory permission. So in order to fix the directory permissions, the pgadmin4 directory has to be owned by 5050, user 5050. So I think it is unique to Ubuntu. So I'm not sure about other platforms, but in Ubuntu, you have to do this in order to get your Postgres admin working. So, yep, if I do that, the pgadmin will start, I guess. I'm just going to open localhost 8086. So where this port comes from, you can go to your Docker Compose file and see here the port 80 of this image is mapped to 8086 of my local system. So if I enter localhost 8086 in my browser, I am actually accessing this pgadmin for web application served from Docker. Okay, you can say pgadmin default email and password is configured here. You can just copy this and enter OpenCV here to log in. So this is the pgadmin. This is actually an optional step, but it will help you if you are going to use PostgreSQL frequently. So I'm just creating a new server. It's actually not creating a server. I'm just connecting to a server. So the host name or address. This is another unique thing to Ubuntu, I guess. You have, if you enter localhost and your username and password, you may not be able to like log in. So this username and password you can find in the same Docker Compose file. You see, OpenCV. The default Postgres login name is Postgres. So I'm just using it. So it is Postgres and OpenCV. As you can see, it is throwing error like localhost port fail. What you have to do in Ubuntu is you can just run docker ps to get all the running containers, and you have to find the Postgres. So you have to find the container ID and docker inspect. Docker inspect and paste the container ID. You will get this IP address of that container. So I just copy the Postgres containers IP. Just Just making sure it is Postgres, not pgadmin. Yeah, it is Postgres. Okay. So now I'm going to paste it here and hopefully we can connect it. Yeah, we are connected to the database. And since I installed it just now, we don't have anything here. Nothing is populated, nothing is available anywhere. So yep, let's just jump to the code and see how to create SQL functions. So this is the first method you have to take care of. Like you have to change the host address here to log into your PostgreSQL server. So these values, Postgres and OpenCV, are already populated in your Docker compose.yaml file. So from there, I already copied these values here, username, password, everything. So it should just run. And also you may have to like save the file once you change this IP. So I'm going to run Python create SQL functions. So done. It just executed the SQL command, and you can see some activity here. And if you refresh, you can find in the schemas, you can find your function generated here. 2 functions are generated, a table is generated here, and this face table is going to be our database. Like it is going to be the storage of our data. Okay, it has an ID with data type bigint. It has a name with varying characters, and it has a face embedding that is double precision array. This is double precision is nothing but a float, and ID is going to be our primary key. So that's all. That's all to the database table and the function. Let's go to the function. So this SQL query will generate 2 functions here. So I'll show you. As you can see, it is the Euclidean distance calculating a SQL function. I'm not going to pretend like I actually understand this. I am not well versed in SQL at all. So this I just got this SQL from some guy in Stack Overflow. Okay, so I just copied this function. So if you have any doubts regarding the SQL function, ask in the comments, but I am not entirely sure how this function works, to be honest. Okay, then let's move on to the face embeddings.py. So here we are going to generate the required embeddings. So in order to do that, we need a LFW dataset. So LFW dataset can be downloaded from Kaggle. LFW dataset, you can just search and get it from Kaggle. So just downloaded it and extracted it in my home directory. So I'm just going to copy the file to this directory here. I'm just going to paste here. So as you can see, it is very huge file. So 13,233 images are there. So yep, it copied. Let's jump here. Let's see. As you can see, LFW is copied to our directory. So I just named it LFW, and yep, this update table function will populate the data from read from the LFW database and just push it through the PostgreSQL. So actually what it is doing is folder exec function is called. So it comes here and just iterate through all the files in the work directory and just reads the file and loads it in image. And we are just calculating the face embedding using the get face embedding method. This method is available in another file called face recognition functions. So here we have multiple functions that we use frequently. Okay. So yep, get face embedding will get the face description or face embedding here, and we are just converting that face embedding vector into Python's built-in list data type so that we can just easily update it into the table. So as you can see, we are just updating it into this method. And yeah, let me execute this function. Python 3 face embeddings.py. This will generate. So yep, I think I haven't changed the IP here, so it will be in face recognition functions. So there it is. Yep. From here I'm just going to copy the IP to the face recognition functions, because this is where our database connection is established in face recognition functions. And I'm just going to run the method again. So as you can see, it is generating the face embedding and just updating it into our pgadmin. You can go to database and see the activity, network activity here. So it is just reading and writing to the PostgreSQL database. So it is just going over all the files in this LFW directory. I am just going to close it now, since it might take lots of time to completely finish this. So I just quit it using Q key, because I added it face embedding to bypass the execution. So here you can see, just press Q when it is running to just break out of the loop, and if you just leave it, it will just execute until the end of LFW. So it will take a very, very long time. So yep, you prepare your data set accordingly. And yep, let's see the face table. So to see that, we can go to query tool. We can just write select from face table. So this will, as you can see, it has calculated 190 190 data face data, and populated our face table. So from this we can like select anything, and we can query for any particular face. So I'm going to do that with the main function. So main.py. So I think I have this harbhajan.jpg in my temp directory. Yep, I have this image here. So this is Harbhajan Singh, Indian cricketer, if you don't know. And we have in our home, we have Harbhajan Singh in the LFW. Okay, Harbhajan. So this is him. Okay. Now I'm just going to run the main function. Just right click and run Python file in terminal. As you can see, it just returned that table, like it is returning 159, which may be the ID, Harbhajan Singh the name, and this is like the actual Harbhajan.jpg, the calculated face embedding. The distance between the calculated face embedding from Harbhajan.jpg and the actual value stored in our database. So let's try another person. Like let's see who else is here. Face table, order by face table name, ascending. Let's see Angelina Jolie. So I'm just going to save this image, naming it as Jolie. So I'm just changing it to jolie.jpg and I'm just running it again. So now it should return Angelina Jolie. Jolie.jpg not available. Why? Jolie.jpg, the name is JPEG. As you can see, it is returning Angelina Jolie, and the Euclidean distance between the actual face, actual input, and the value stored in the database is 0.4799. So that's it. So you can do with your face also with by using your face embeddings.py and changing it from folder execution to CAM execution. But I'm not sure about the accuracy. Okay, let's try it with my face. Before doing that, make sure you use an ID that is larger than actual number of entries in your database, because this value will, if it is, let's say if it is 169, it will erase this Angelina Jolie and populate my face value in there. So I'm just going with 1001. So hope that makes sense. I'm going to run this. Python 3 face embeddings.py. So the frame rate is not good when it is detecting the face. So I'm just pressing R. So it says updated successfully here. So you can just press Q and exit out of this. So now if you go to your pgadmin 4 and run this query again, at 1001 you can find your face embedding. Yeah, here it is. You can see my face embedding is stored here, and I'm just going to run it with my own face, one of my stored image. Let's see how it goes. So to home, pictures, and this is me. I'm just going to store it in temp directory. So we are going to run it in main. Out.jpg is my file, I guess. Yeah, out.jpg. I'm just going to run this. Python 3 main.py. It should return Rajesh. Yeah, it returns Rajesh. So I think it helps someone. So if you have any doubt, just ping me, or you can just contact me via my Instagram or via Twitter. I'll leave the link in the description. So have a good day. Bye.